also driving.
When I think about chips for AI compute, I tend to think there is training and then there is inference, as you alluded to, which is when it's used for driving. Are you using both? Is it just inference right now?
Yeah, good question. So as you mentioned, you will typically, I guess hardware for deep learning actually kind of has like two broad areas now. There's hardware you would use to train neural networks, and that looks very different from the hardware you might want to use to run a neural network. So running a neural network is computationally much more straightforward thing. The neurons just have to fire in a sequence. If you're training a neural network, there's a lot more that goes on there because you have to run the neural network forward, but then you also have to implement the backpropagation algorithm, and you have to run the backward pass, and you have to update the weights. And there's a lot of technical details as to like at what precision do you run all this mathematical precision in terms of the numbers involved. And so there's a lot of details that make the training a much more heavy endeavor, and the testing, the inference, a much simpler endeavor. And so, as you mentioned, we currently have a chip for inference that we own and we've designed and is in double the cars. And we are also working on a training computer, and this is Project Dojo. And Elon has sort of alluded to it on a high level a number of times. And it is really just pushing this co-design even further. And we have a rough understanding of what these computational workflows look like for training neural networks for the autopilot. It's a massive amount of video training. We are building a chip directly sort of designed for that kind of a computational workload. And so, yeah, that's absolutely an active project currently at Tesla.
I'm curious about your thoughts. I mean, you were at OpenAI, you're one of the founding members, and OpenAI somewhat recently raised $1 billion with specifically compute in mind. And so I'm curious about that strategic angle also. Is that something on your mind, that more compute is the only way to succeed in AI?
Yeah, I think more compute is one of the fundamental limiting blocks right now for a lot of things, for a lot of domains. OpenAI is right now focused on, for example, natural language processing, for example, with their most recent work on GPT. So what they're doing there is it's a language modeling task where the neural network is generating language, text. And so you can feed it text and it will continue text, or you can ask it to produce text with certain properties, or it will answer your questions, or it will talk to you. So what's happening there is the algorithms, again, in this setting are actually quite well known and understood. As you mentioned, the neural network takes the form of this transformer. You're training it in a very kind of standard regime with backpropagation, stochastic gradient, and so on. So that's understood. So the algorithms are not the bottleneck. The data set is also not a bottleneck for that class of problems because we have the internet with a huge amount of text. So in that regime, so you are not upper bounded by data sets, but you are upper bounded by the compute available to you, which really restricts the size of the model that you can actually use. And like I said, in deep learning, we are blessed with algorithms that seem to continue to work better and better as you just make them bigger. You're literally just adding neurons into the system and it works better. And so OpenAI is primarily gated by compute in this setting. If they could train a bigger network, it would work better. And that's not the way it used to be in AI. We used to be bottlenecked by algorithms. And so what a beautiful place to be. If they could just run a bigger network, it would work much better. And the results would be even more magical.
And is that true for Tesla also?
Yes, I would say so. And neural networks have this property in general that, yeah, if you make them bigger, they will almost always work better. And, you know, in the limit, you can, for example, use, this is slightly more technical, but you could use model ensembles, you could use dropout, and a lot of techniques to basically make sure that these models work better when you scale them up. And so we are also limited by compute to a large extent, and we have to be very creative in how we squeeze out all the juice from all the flops that we have available on the car. And so that's the case also on the car, but also during training for us, right? So you want to train as big of a network as possible. And for us also, you have to consider the data set and to whatever extent that is a bottleneck, and the algorithms and the models and to whatever extent that is a bottleneck. And so for us, for example, we do a lot of manual labeling, but we are also looking into ways that you can train on data without having to label with a human. You can use sensors, expensive sensors, to annotate your data. Maybe you have a few cars that drive around with, say, radars or lidars or any other sensing suite you want that gives you extra information about the scene, and that can function as annotation for computer vision. And so computer vision can be matching those sensors and imitating them. And so you have sensor annotation, human annotation, or self-annotation, like predicting the future. And so all of those are knobs and kind of algorithms you could play with.
Now, Tesla company trying to build self-driving cars. There's other efforts out there. Sometimes, at least in the media, it's depicted as a bit of a race of who's going to get there first and so forth. And how do you see the Tesla effort different from the other efforts?
It's a very good question because it is very different and it is not obvious. So, for example, there was a video just recently released where someone used a Waymo car and the Waymo drove them to some location. I forget the details. And then they used the Tesla Autopilot full self-driving beta build and it also drove them